Alright guys, in this video we're going to learn how to use 45, 45, 90 triangles as well as 30, 60, 90 triangles. Alright, so these are your two common similar triangles that we're going to be using and applying to different scenarios, as well as right triangle similarity, or that will tie into right triangle similarity. So the first thing we want to look at are the 45, 45, 90 triangles. Now what makes these triangles special with the 45, 45, 90 triangle, so specifically looking at this triangle right here, we can look at the right angle that's indicated by the box in one of the corners of the triangle, and then we have two angle marks that are identical. So we know right away that that box represents 90 degrees. So then the two angle marks indicate that these are congruent angles, and all the angles inside of the triangle add up to 180 degrees. So if I take 90 plus 45 plus 45, that should equal 180 degrees, which means that these two angles are 45 degrees and 45 degrees. Now, in comparison of the side lengths in this specific triangle, we've learned that the sides across from the angles that are inside of the triangle can determine the size comparison of each side. So for example, since we have two 45, 45 angles, our degree angles in our triangle, the sides across of them have to be congruent. So we're going to mark that with an X, because we don't know necessarily how big that triangle is, but we just know whatever it is, they're the same measurement. Now the hypotenuse of that 45, 45, 90 triangle in comparison to the two legs is always equal to the side times root 2. So in a 45, 45, 90 triangle, this is how all the sides are related to one another. Two of the legs are congruent, and then the hypotenuse is always root 2 times more than one of the side lengths. Now for a 30, 60, 90 triangle here, we have our right angle here. Okay, so then we know that just based on looking at the angles, if we're going to talk about specifically a 30, 60, 90 triangle, the bigger angle is going to be 60 degrees, the smaller angles will be 30. So then if you add up all the interior angles inside, you should get 180 degrees. Now, similarly to the 45, 45, 90 triangles, we're going to talk about how the side lengths are related to one another and how they compare. So the side with the 60, the shorter side, we're going to call that X. That'll be our first side length that we're working with. We have our hypotenuse across from the right angle, and there's our X. So then how the rest of the sides of the triangle compare to the short side of a 30, 60, 90 triangle? Well, the hypotenuse is always double the size of this short leg. So we have 2 times X. And then I immediately wrote down how this longer side of the two legs compare. Well, the long side of the 30, 60, 90 triangle is always root 3 times more than the short side. So we start with the short side of a 30, 60, 90 triangle as our base as X, and then our hypotenuse is always double the amount, and then our long leg is always our short leg, but scaled by root 3. Okay, so let's apply the 45, 45, 90 triangle, or even a 30, 60, 90 triangle. So we're looking at the diagram. It says, in example 1, what are the lengths of the legs of this triangle? So what might stick out to you is that we have tick marks here that indicate that we have two congruent sides. We have a right angle here. So then, because we have two congruent sides and a right angle, then we know that this is 45 degrees as well as this angle right here. So this is a 45, 45, 90 triangle. So then we learned that the legs of a 45, 45, 90 triangle are your X's, some unknown value, and the hypotenuse is always the leg times root 2. So this root 72 is represented by represents the hypotenuse. So if we're going to try to figure out what the lengths of the legs are, well, root 72 was determined by the fact that it is equal to the short legs, or the legs, times root 2. So if I set up my equation, root 72 is equal to the legs times root 2, I can start solving for X. And X represents the legs of this 45, 45, 90 triangle. So I'm going to divide both sides by root 2. So then root 72 divided by root 2 ends up being root 36. And then if I take the square root of 36, the side length of a 45, 45, 90 triangle, specifically this one with a hypotenuse of root 72, is the value of 6. Alright, in example 2, it's a little trickier. It says, what are the angles of this triangle? So if you look at the diagram, we notice that we have our right angle. We have an angle mark here and 2 angle marks here that indicate that these are different angles. Now we're going to pay our attention to the side lengths and look at the short side, the hypotenuse, and the longer side. So the short side is 4, let's call that x, and then we look at how the other sides are compared to that short side. Well, the hypotenuse seems to be double the amount of the short side. And so if I'm following that pattern, it looks like we're going to be working with a 30, 60, 90 triangle. So we're just going to double check that. So we're going to assume that this is 60 degrees, this is 30 degrees. I just want to double check to see if that's true. So then my root 48, this longer leg, has to be the short leg, but multiplied by a square root of 3. So let's see if root 48 is actually the short leg times root 3. So I'm going to have to break down root 48. So when I simplify the radical of root 48, I'm pulling out any perfect squares that I can. So I'm going to break down 48 to be 6 times 8, or square root of 6 times 8. So then if I simplify 6, you get 3 and 2, and if I simplify 8, you get 4 and 2. So then I know that the square root, I have a pair of 2's, so then I'm going to pull that out outside of the radical. And then the square root of 4 ends up being just 2. So then I'm left with a radical 3 inside the radical. So then my final simplification of square root 48 ends up being 4 root 3, which is the short leg times the radical 3. So then using the 30, 60, 90 triangle, that helped us determine what the angles are inside and confirm that the side lengths and how they're related to one another. So then we can say that this triangle specifically is a 30, 60, 90 triangle, and we use the ratios of the sides in comparison to one another to figure out, well, how does the short leg compare to the hypotenuse to the long leg as well.